Here we have the 2015 Relative Velocity Question 2b. A woman falling vertically by parachute in a steady downpour of rain observes that when her speed is 5 meters per second, she's coming down like this at 5 meters per second. The velocity of the woman is equal to 0 in the I direction minus 5 in the J direction. The rain appears. Okay, so we're going to be looking at the velocity of the rain here. Let's let the velocity of the rain equal A in the I direction plus B in the J direction. And the rain appears, so that's the velocity of the rain relative to the woman. It appears to make an angle of 45 degrees with the vertical. So she's coming down, the 45 is in here. So with 45, we can say the x and the y are the same. We don't know the speed, so let's call the speed p here. So we can just say it's coming into the positive negative sector. So p in the I direction minus p in the j direction might be the easiest way to look at this. So we have the velocity of the rain, the velocity of a woman, so we can create the velocity the rain relative to the woman, another equation for it, with the velocity of the rain minus the velocity of the woman. So this is going to be A minus 0, so just A in the I direction, and then plus, it's going to be B minus 5, B plus 5 in the J direction. So that's the velocity of the rain relative to the woman. Now, the second scenario, when her speed is 3 meters per second, so the velocity of the woman is equal to 0 in the I direction minus 3 in the J direction. The velocity of the rain hasn't changed, but now it appears to make an angle of 30 with the vertical. So we have this scenario here, 30 is in here, so the I is opposite this, so we don't know the speed of the rain. So we're going to have to give it a letter here. So why don't we call the velocity of the rain, let's call it u sine 30 in the I direction minus u cos 30 in the j direction, which will be u, sorry, this is the rain, how it appears to the woman, u over 2 in the I direction minus root 3u over 2 in the j direction. And we also have the velocity of the rain relative to the woman with the velocity of the rain minus the velocity of the woman with our new speed of 3. So the velocity of the rain, again, A minus 0, so just A in the I direction. And then we have plus, it's going to be B plus 3 in the j direction. So if we equate these, we're going to get A is equal to u over 2, and we're going to get B plus 3 is going to be equal to minus root 3 u over 2. And on this side, we can say that A is equal to P. We're equating this one and this one. And we can say B plus 5 is equal to minus P. So we have A, P, B, U, 4 unknowns, so we need to just get rid of a few of these here. Straight away we can say here that B plus 5, if A is equal to P, is equal to minus A. So if we want to replace this A, we can say that A is equal to minus B minus 5. So minus B minus 5 is equal to U over 2. So we could get, let's solve for B. So we're going to get minus 2B minus 10 is equal to U. And on this side we could get 2B plus 6 is going to be equal to minus root 3U. So divided by minus root 3 is equal to U. So if I equate these two things, I'm going to get minus 2b minus 10 equals 2b plus 6 over minus root 3. If I multiply by minus root 3, I'm going to get 2 root 3b plus 10 root 3 equals 2b plus 6. So I am going to get 2 root 3b minus 2b, 2 root 3b minus 2b is equal to 6 minus 10 root 3. Might decimalize these. This gives me 1.4641b. That's going to be equal to minus 11.3205, so we say 321. So that will give me a value of b of minus 7.732, and we know that a is equal to minus b minus 5, so a is equal to minus b, which will be 7.732 minus 5, which is 2.732. So eventually we get to the velocity of rain with these crazy amount of unknowns. It's going to be equal to 2.732 in the I direction minus 7.732 in the J direction. The magnitude of the velocity of the rain is the square root of these two things squared and added together. This is going to give me 8.20, just 8.2. I presume we're dealing in meters per second here. I haven't looked. Meters per second. Meters per second, and the angle will be with the vertical. The inverse tan of theta is equal to 7. Actually, it will be with the vertical, so it'll be like this. So the angle will have the I, for the vertical angle, the I over the J. So it's going to be turned around. In this case, it's going to be 2.732 over 7.732 will give me theta, and theta in this case is 19.5 degrees. Tricky enough question in 2015.